Welcome to this lesson on solving systems of linear equations using the substitution method. This technique is useful when we have two equations with two unknowns, like x and y. The substitution method follows four key steps. First, we solve one equation for one variable, usually expressing y in terms of x. Second, we substitute that expression into the other equation. Third, we solve the resulting single variable equation. And finally, we back substitute to find the value of the second variable. Let's work through an example to see how this method works in practice. Consider the system of equations. Equation 1, 2x plus 3, y equals 12. Equation 2x minus y equals 1. Let's start with step 1. We'll solve equation 2 for x. From x minus y equals 1, we can rearrange to get x equals y plus 1. This is the expression we'll substitute into the first equation. Now for step 2, we substitute the expression x equals y plus 1 into equation 1. This gives us 2 times open parenthesis, y plus 1 close parenthesis plus 3, y equals 12. For step 3, we solve this equation for y. Let's distribute the 2, getting 2y plus 2 plus 3, y equals 12. Combining like terms, we have 5y plus 2 equals 12. Subtracting 2 from both sides, we get 5y equals 10. Finally, dividing by 5, we find that y equals 2. For the fourth and final step, we back substitute y equals 2 into our expression for x, which was x equals y plus 1. This gives us x equals 2 plus 1, or x equals 3. So our solution is the ordered pair 3, 2. Let's verify our solution by checking if the point 3, 2 satisfies both of our original equations. For equation 1, we have 2 times 3 plus 3 times 2, which is 6 plus 6, equals 12. This is true. For equation 2, we have 3 minus 2 equals 1. This is also true. Graphically, this means that the point 3, 2 is exactly where these two lines intersect. Let's try another example to reinforce our understanding. This time, let's solve the system. Equation 1. 4x minus y equals 5. Equation 2, 2x plus 3y equals 1. Starting with step 1, we'll solve equation 1 for y. From 4x minus y equals 5, we can rearrange to get negative y equals 5 minus 4x, which means y equals 4x minus 5. For step 2, we substitute y equals 4x minus 5 into equation 2. This gives us 2x plus 3 times open parenthesis 4x minus 5 close parenthesis equals 1. For step 3, we solve for x. Distributing the 3, we get 2x plus 12x minus 15 equals 1. Combining like terms, 14x minus 15 equals 1. Adding 15 to both sides, we get 14x equals 16. Dividing by 14, we find that x equals 16 over 14, which simplifies to 8/7. For the final step, we back substitute x equals 8/7 into our expression for y, which was y equals 4x minus 5. This gives us y equals 4 times 8/7 minus 5. Simplifying, we get y equals 32/7 minus 5, which equals 32/7 minus 35/7, giving us negative 3/7. So our solution is the ordered pair 8/7, negative 3/7. Let's verify this solution graphically. Here are the two lines from our system. 4x minus y equals 5 in orange, and 2x plus 3 y equals 1 in blue. As we can see, they intersect at the point 8/7, negative 3/7, which is approximately 1.14 minus 0.43 in decimal form. Let's summarize what we've learned about solving systems of linear equations by substitution. The substitution method works by: first, solving one equation for one variable. Second, substituting that expression into the other equation. Third, solving for the remaining variable. And finally, back substituting to find the other variable. Some helpful tips. Always isolate the variable completely before substituting. Choose the equation that's easier to solve for one variable. And always check your solution in both original equations. With practice, you'll find that the substitution method becomes a quick and reliable approach to solving systems of linear equations.